Hello, and welcome back to Medical Compliance with Clarissa. I'm Clarissa Benfield, our Global Director and Business Line Leader here at Intertek. And today I am so thrilled to be joined by Rich Byczek, who is one of our Global Technical Directors. Rich, thank you so much for joining me today. How are you doing?
I'm doing great. Thank you.
Wonderful. Well, maybe you can start off by giving everybody a bit of an introduction to yourself and your background. We're going to talk all things batteries today, so maybe you can give a brief intro to how you got into this space.
Sure. I'm the Global Technical Director here at Intertek. I'm based in the Plymouth, Michigan lab, which is one of our automotive centers in our Transportation Technologies group. And as the technical director, I'm also our technical lead for electric vehicles and energy storage, which is how we got into focusing on batteries here. We're typically testing larger electric vehicle and stationary batteries, but then that translates down to the smaller consumer, medical, industrial products as well. I've been doing this role since about 2010, and I've been with Intertek almost 20 years now.
Wow, wonderful. So you've seen it all, right? Everything from the big batteries to the small batteries, as well as, right, everything we're seeing with battery trends and moving more towards that direction, right?
Exactly. And obviously the focus is heavily on lithium and lithium ion batteries. So that has been our focus as well. And a lot of the regulations and test standards and I would say trends that we're seeing are geared towards lithium ion batteries in particular.
Wonderful. Well, I think today we'll focus a little bit on the medical batteries, as well as, you mentioned some of the more like consumer product type batteries, because we're seeing in our industry such a convergence between medical manufacturers and more of the like small appliances, consumer type good manufacturers. So, just in general, you see it all. You've been with Intertek a long time. You've seen a lot of different types of batteries, different types of applications. What are you seeing just from an overall trends perspective in the industry, especially with the move from, things that are more cord connected to this idea of everything being battery storage and being able to move things around and rechargeable? What are you seeing?
Yeah, so definitely seeing a heavy trend towards more battery powered devices. Obviously that it adds a lot of flexibility for people, especially for wearable devices, transportable devices. People want to carry things with them without having to plug in.
Yeah.
It gives a lot of freedom there. From a compliance standpoint, sometimes having something that's battery powered can simplify some of the designs as well. So you can use some other off the shelf products for chargers and things, and just focus on developing your product in the low voltage realm. From a safety standpoint, there's some trade-offs with batteries we'll talk about a bit, I think, here.
Yeah.
But you also get away from having, for example, on those wearable devices that you have a direct connection to the wall mains, the 120 volt or 240 volt mains, which again adds a layer of safety just inherently that you're not dealing with connecting to the wall power. So batteries can be a bit of a simplifier in some of the designs, but it brings its own separate hazards and risks.
Yeah, and it's so interesting too, because I think also just we're seeing this idea, as consumers ourselves, right? Like people want everything to be easy, right? You talk about the wearable devices. We're seeing such a move towards that with medical products. You want to be able to charge something and then walk away with it, use it in a different room, take it with you when you're going places. And I just, I don't think that's going to be going anywhere anytime soon. And so it's interesting when we're chatting with our manufacturers, just how much they want to move towards this space. So you mentioned a couple of things, right, with regulations and design. So at what point should a manufacturer be considering batteries as part of their design? Like, how do you get prepared in regards to that?
Right. So, I would say that there's two paths here. One is when you're doing a retrofit to an existing product that maybe is using like a lead acid battery or an older technology, alkaline batteries, and you want to switch to either a lithium cell or lithium ion rechargeable type. Definitely you've got a product that's somewhat already designed and you want to somehow retrofit it for the new battery. The biggest concerns I see there when manufacturers are working with, say, contract manufacturers for this, they may or may not be fully aware of the differences of the batteries that you're requesting. So we often work with those suppliers or those clients really to make sure they're picking the right battery for the application. You're replacing something that you already had. You want to get more life out of it. You want to get a higher power out of it. There's different goals for every product. And that would also translate to those new designs where it's a fresh design, or you're trying to just completely get away from the cord. The first step early on, it's really making sure you pick the right battery. We talk about lithium ion batteries. Sometimes that's not the right choice for you. Something simple like a basic alkaline battery that you use in your remote control at home is going to be perfectly suitable for certain devices because they draw very little power or they use intermittently, and the convenience of having an off-the-shelf store-bought alkaline battery is going to outweigh the potential technological advantages of having a rechargeable lithium ion, and that's a downfall, I would say, or a pitfall clients can often go into. They just pick a battery because it's the same as they've seen on their cell phones or another product and assume that's what they need. And if you're not, connected to the cellular network 24 hours a day and downloading video games, etc., you don't need that kind of power. So that's, to be honest, that's an area that clients really should be aware of, is understanding the needs, power, energy, duration for those batteries, and they can often pick the safer option up front and save themselves a lot of complications later in the compliance program.
Yeah, that's such an interesting thought too, right? Just selecting something because it's something that you've seen before, something that's easy that, you may go down one path without really considering all of your options. And with batteries too, right? We have power supplies, of course, there's specific standards. So batteries, of course, have standards as well. Maybe you can touch on some of these when you're talking about purchasing an off-the-shelf battery or something that's already approved to the specific battery standards. I know there are some that, we have to follow in the medical space. So maybe you can touch on that a little bit as part of this design process. Yeah.
So again, obviously, when we're working with our medical clients, we're typically helping them get certified according to the 60601 series of standards for the medical device itself. Because it's a globally harmonized standard base, we also point typically to the globally harmonized battery standards, and that's typically IEC 62133-2, which is specific to lithium ion rechargeable cells and batteries. There are multiple certification schemes. It's adopted and harmonized here in the US and Canada as a UL standard and as a CSA standard. So it can be utilized essentially globally. So that's usually where we direct clients toward for getting the component cells and batteries certified. And that eases the compliance process at the end product because we don't have to necessarily go back and rerun all those tests.
Yeah. So sometimes we'll see the batteries are approved right off the shelf, as you mentioned. Other times we'll see instances that maybe someone wants to develop their own battery and have it tested. And of course we can do that too. So, when we're looking at different types of products where maybe someone is developing their own pack or creating it based on cells, what should people be considering when they're doing that, right? If you're taking approved cells and making a battery pack, or it has to fit, in a certain handle or something for a compact medical type device.
Right. So I mentioned with that 62133-2 standard, there's what we call cell level and battery level tests. And a battery pack or battery that you use in a device may consist of one or more of those building block individual cells. And I think we've all seen cells that look like a AA battery, or there might be a little pouch. And sometimes the device is going to need more than one. So you have what we call a battery pack of maybe one or maybe more than one cells. Generally speaking, our clients device manufacturers are not building their own battery cells. So when you're going to buy that cell, at least call it off the shelf or through your distributor, you're going to want to look for one that already has one of those certifications in place, like 62133-2, and just save yourself the effort of potentially having a battery that's non-compliant, as well as going through, saving that step in your process by having one already certified. When you then take that cell and build it into a battery pack, we have the 62133-2 as guidance, but there's also some other standards that guide us in terms of evaluating the battery as it's integrated in the product. Many new products now, especially your smaller devices, just picture your laptop, your cell phone, your tablets.
Everything that surrounds us.
Pretty much everything that we use, you don't have removable battery packs anymore. I picture my old HP laptop. When I first started here, I had 2 or 3 battery packs that I carried around in my backpack, and I would swap them out, and I'd have the high capacity, etc. Those would be certified kind of differently because they were standalone batteries that you plugged them into a charger. You might connect them to another device. Now they're integrated to the product, and the safety circuits aren't necessarily on the battery. They're distributed throughout the product. We're often charging through a common wireless or a USB type of port. So we're relying on a secondary charging circuit to provide the safeties during charging for the battery. So it's difficult to draw a dotted line around what is the battery pack. And instead,
Yeah.
we have to consider the functions. You're charging the battery, you're utilizing the battery as a power supply, and you're also trying to protect it from mechanical and environmental stresses. So there are several standards. There's in the ANSI UL world, we have UL 2595, which kind of helps consider the battery as part of the product. And there are several corollary standards on the IEC side that allow us to evaluate the battery as part of the product. It's not directly written in the medical device standards. So we often do a design review with clients to understand whether or not it's really a standalone battery pack, whether or not it has certified cells, and whether or not we need to evaluate it as part of the entire product rather than just as a component.
Yeah, and I think it was really interesting too that you mentioned, right? I think sometimes people forget or maybe fail to realize that it's not just, oh, we have all of these cells that have this approval to the 62133 standard. We're putting them together. They should be approved because now they were all approved individually, right? It's considering both of those elements, the cells individually, as well as then once you couple them together in some certain way, regardless of what you're doing, it then requires its own level of testing and approval.
Yeah, the core cell standard is really helping to make sure that the construction of that cell is robust, following best practices, and under a worst case condition, that cell will, if you will, fail safely. It will vent or rupture or disable itself. However, at the battery and the device level, we're really concerned with what we call the BMS, battery management system. Those functions where we're making sure that we don't overcharge the battery either through voltage or current. We're not allowing the battery to operate in temperatures outside of its normal usage range. So the cell manufacturer defines a temperature range, minimum maximum voltages, minimum maximum currents that can be applied. And the battery management system is there to regulate those. And that's really what we're evaluating at the device level, since that BMS is, again, integrated throughout the device and may not be a discrete component of the battery.
Yeah. So let's talk about too, right? So you are choosing to use cells and you're creating a pack, or you need to do some of your own battery testing. What are we talking in terms of how long does this take, right? How many samples do you have to provide, right? Because I think, sometimes we get used to the idea of just a couple of samples for safety testing and we get the testing done, or a couple for EMC, but maybe walk us through that process a little bit.
Sure. So there's a wide range there. Again, if you've got uncertified cells and you have to essentially go through the process of evaluating the cells themselves, that can get into a high sample count, but it's just of the individual cells, typically in the range of about 30 to 50 cells. And there's a couple different variations of the standards, like the IEC standard. But at the battery pack level, assuming you have certified cells, typically we're in the range of around 12 samples to 15 samples that are needed. And the reason for the additional samples, typically, as you mentioned, end products, we're looking at one representative device, but generally for the battery tests, because they can be somewhat destructive, we're usually looking to have additional samples. You may have to test every test on 3 samples or 5 samples rather than just one. And often because of the nature of those tests, the stress levels we're applying, you can't necessarily reuse those samples.
Yeah, we're assuming we're not getting those batteries back, right?
Exactly. Yeah. I mean, we're pushing them to make sure that they go into a fail-safe mode, or we're driving them to essentially to rupture or vent or blow a fuse. And often, especially for those integrated batteries, it's non-reusable at that point. It's essentially in a fail-safe mode, and we're gonna have to dispose of that battery and grab a new sample for the next test. So that's, generally speaking, you can get by with around 12 samples under most, say, common designs that we see.
And when we're putting the stress on the batteries and doing the testing, how long does this take? Are we talking a couple of days, a couple of weeks? Because I know there's cycling testing and things that you have to do in order to make sure that they can comply.
So for a couple of different reasons, that it's generally in the order of weeks versus days. An individual test may take 1 or 2 days, but generally speaking, we've got to use ruggedized facilities because of the potential hazards. These batteries, there's a risk of explosion, there's a risk of fire. So we do have, would say, somewhat limited facilities that are set up to handle those tests. You're generally running the test 1 sample at a time, not 4 or 5. All at the same time because of those potential hazards. But some of the tests will have like you said, charge and discharge prior to the test. We want to stabilize temperatures. That may take a day. After a test, because of some of the concerns with latent failures in batteries, part of the test condition is wait 7 days, for example, and make sure that there's no temperature rise, there's no latent damage to the battery, and then do a post-test evaluation. So just built into the tests themselves, duration could be more than 1 week just for one test.
Yeah. So there's all of that testing that goes into it, right? Either you're purchasing off the shelf, as you mentioned, or you decide to test your own battery, it gets certified, you're ready to go. Now it becomes a component as part of your larger system, either as a standalone, that's the only source of power, or it's also cord connected or rechargeable in some way, right? So you touched a little bit too on, this integration of batteries into a system, right? Into a medical device in general, and the risks and how that impacts some of the other areas of testing, be it, safety or EMC, global approvals for batteries. So anything kind of in that realm, once you get to that spot, right now you have this battery, it's approved, right? We know it has to be approved for an end device, right? For use in reports. But what about, the risk that we see as part of the device, or, what that might impact in terms of overall testing?
Right. So the overall device testing usually, I would say, doesn't make it more complicated when you have a battery versus a cord connected device. It'll depend more on the charging circuits. If you're going to now integrate the charging circuit onto the device, then that circuit would have its own evaluation, and you potentially have, some additional EMC concerns there. If you're going to try to use wireless charging, you've got some concerns there about evaluating that charging interface. But generally speaking, when you're switching from a cord connected device to a battery powered device, and it's only going to be connected through a USB or some other standard interface for charging, it often simplifies some of those requirements. Some of the conducted concerns we have, connecting to a wall, that is covered within the offboard charger, that USB charger itself, and the device, the actual device with the battery in it would actually have some, reduced requirements there, because we're not connecting to wall mains. For global compliance, there can be some nuances there, because batteries, especially again, lithium ion batteries, are regulated somewhat differently in different parts of the world because of obviously, publicized events or issues that have happened with newly designed batteries. And you may have, for example, the 62133-2 standard I mentioned may or may not have been adopted in an individual country. They may still be, if you will, on the books, is the older version of the standard. And even though you've gone through the new version of the standard and you want to import to a certain country, now you have to deal with a bit of a delta test, go back and certify that same battery to an older version of the standard, or a different variation of one of those standards. Some, countries, Japan, for example, they're referring to the IEC standard, but they do have a kind of a subset of their own requirements we call national deviations that you do have to be concerned with. The second, I would say, major concern with the global approvals, often we're talking here about medical devices. We're approving the battery as part of that medical device. But even though they may or may not be user replaceable, they may be a service part where you have to replace a battery pack within the device. And then you run into the concern that now when I import those batteries into a specific market, a specific country, it's not a medical device that has a battery. It's a standalone battery as a service part. And while a component level evaluation may have been sufficient for the end product, certain countries may regulate standalone batteries separately and require separate markings or separate labeling just on those batteries. So that's really one of the gotchas here, is we can certify a product, and it's not till a year later that a client would have to start providing service parts in bulk, and they realize there's some additional requirements on them.
And I think that's such a good point. We've talked about this on a few of our other podcasts as it relates to global approvals of medical devices, because you really do need to know, or at least have some idea of, where you're trying to go with the product, thinking, 6 months out, 2 years out, 5 years out, just as you're putting together your regulatory plan, because there are so many nuances with some of these countries in terms of specific approvals, like you mentioned, for the batteries and transporting them into the country, or you think, wireless requirements, connectivity requirements. And so it's why, we talk so much about, identifying what your regulatory pathway is and what your plan is up front, to sort of have that idea of, where you're trying to go. The other thing that you mentioned that I would like to dive a little bit further into. So we've talked about lithium batteries a little bit. I know there's some of the requirements that, people ask a lot of questions about when you're transporting batteries, right? So for, when you're shipping them yourself or when they're shipping as part of the product. So maybe we can go into that a little bit, because I know that's been a hot topic and a big area of maybe concern over the last few years as we've seen some of these requirements.
Yeah. And there's, separate from the product safety certification requirements. And that's one of the key points here, not to confuse the two. We see clients will go ahead and have a battery tested and shown to be compliant for transportation regulations, and they assume that means it's certified for use in an end product, and it's not always the case. And the opposite is also true. A certified battery with our mark on it or a CD scheme certificate doesn't necessarily mean that battery is considered safe for transportation. So in the dangerous goods realm, lithium and lithium ion batteries are treated as what we call class 9 dangerous goods. They're not flammable, they're not explosive, but they could cause a potential hazard in transportation and in handling, and that's regardless of whether it's being utilized in the product. It's just as something shipped in a cardboard box in a pallet. And so there's what we call the UN 38.3 test regime that the battery has to go through. And again, when you buy a cell off the shelf, most likely that manufacturer's already done the cell level testing there. But then when you go ahead and design your own battery pack and integrate it into your product, or just build your own standalone battery pack, there is a battery level set of tests that have to be performed on those same batteries according to the UN 38.3 transportation regulation. And that's another gotcha for people that aren't so used to dealing with lithium batteries specifically, that they don't realize there's that second step, and that can become a concern during the prototype stage when you're trying to ship first samples. It makes it more difficult to ship a battery if it hasn't already gone through that 38.3 regime. You have to treat it essentially as a dangerous good, and it's going to have much more restrictive packaging and shipping labeling requirements just on that container. And again, when we talk about the spare parts batteries, the packaging and labeling requirements just for a shipment that you're going to send through FedEx or a courier of some sort, the requirements for a product with a lithium battery inside of it versus the requirements and limitations on shipping individual lithium batteries in bulk are very different. So not only on the compliance side, but also on the transportation and shipping handling side, we have to be aware of those additional requirements, because these batteries have pose a separate risk when they're being potentially abused in transit.
Yeah. So if I'm a manufacturer and I'm purchasing, I think I understood you right. Like if I'm purchasing a cell from a known cell supplier, right, I can assume that they would have heard of UN 38.3 and likely would have tested to that standard for their cells. You can always ask them that, right? And they would, if they would know what you're talking about, right? Very clear industry standard, right? And then on the pack level as well, if I'm purchasing a pre-designed off-the-shelf battery pack, likely they would have heard of the standard or maybe have tested to it already. And so it's something that, you should be aware of, as a manufacturer sourcing a battery or cells individually, of these additional requirements outside of what's required for the battery itself.
Yes, presumably, like you said, they've already tested that standard because they're shipping you batteries.
Presumably, yes.
Presumably. Right. But again, when you start getting into integrating these cells into your own design, where you no longer have a cell, but you have a battery, even in your, a typical laptop that might have more than one cell, that laptop essentially becomes a battery pack because it's got more power, higher voltage, higher current available than a single cell. So from a transportation concern, it's got more energy, it's got a higher potential for creating a hazard, and needs to go through some testing. And again, when you're not buying them necessarily off the shelf and you're integrating or making your own designs, that's really where manufacturers need to be aware of those requirements. When you're buying it from a distributor or a third party, they should be able to provide you evidence that battery has passed those requirements. And you would want that for your own compliance records, because when you subsequently ship those batteries, rather than going through and retesting them, you show that you have evidence that these batteries have already been proven safe for transport.
And this kind of leads to the last thing I want to chat with you a little bit about today, because obviously such a hot topic as well. We mentioned suppliers and sourcing, different cells, different packs. So let's talk about the supply issues, right? With if you're a manufacturer and you're trying to select a battery, or the battery that you're currently using, you no longer can find a supplier for that, or it's gone obsolete, or you're being forced to change. What do we kind of advise my manufacturers as they're going through this process? I mean, we know it's a really tough time right now to get anything. And if you're trying to get a high volume of, different types of cells or packs, like what would we tell people?
So, there's two paths there again. The first is those that are running into supply chain issues, and we see that quite a bit. First off, again, it's not always easy to just pick one off the shelf because of a rating label. I mentioned earlier, understanding the usage case for that battery, just because it has a couple of the same numbers on the label doesn't mean it's going to work the same. I used that example before for remote control for your TV. You can use the same rated battery and it might last a year in that remote control, and another battery with the same number ratings could last maybe a few days because they're designed for different usage profiles. You really have to, from a design standpoint, understand the differences there when you select an alternate battery or a new supplier. On the compliance side, it's really just the same testing required for that alternate cell, but really to be aware that just because they have the same few numbers on the side, there's more to the data sheet than just those base values. For those that are coming up with new designs, and we see this a lot, and we recommend this strongly, that if you have a potential alternate supplier, if you're already working with multiple vendors for batteries, or even with the same battery vendor, and you know that they're planning in obsolescence, they're going to change that model in a year, we often recommend getting that taken care of right up front. Again, if it's an already certified cell, we can show that it's more or less equivalent to the existing, especially if it's the same manufacturer or the same mounting means you're not doing anything different other than purchasing it from supplier B. We can often incorporate that up front in our end product evaluation, even if you're not currently using that second battery. And that just gives you that flexibility, knowing that down the road when you might run into issues, or you're planning to change in a few months, you don't have to go back and rerun that whole compliance program. You've already kind of taken care of it up front. So it's a little bit of additional cost up front, but generally saves a lot of delays later on when you do have to make that running change or that sudden switch because of supply chain differences. And I would say a lot of clients are looking for not just alternate suppliers, but also alternate locations for those suppliers, different countries, because of things like COVID restrictions and that, you don't know who or where may have some lockdowns or other, concerns going on. I need to have a separate source just from a physical location on the planet that may be able to get me parts quicker. So be aware of that up front and have a few alternate options for your battery up front, even if you're not necessarily intending to use those right away.
Yeah, I think that's such a great piece of advice, right? And I think of all the things that we learned going through the last few years of the pandemic, right? I think it's really forced people to look at their supply chains and how they're sourcing components and how they're sourcing different things, because we haven't ever been put in these really tough positions before, right? Where we are now, to your point, right? Where there could be lockdown restrictions, political restrictions, right? So many things that are going on in our world that if you're trying to get something from a specific geography, or if you're trying to get, a specific supplier to, send you something, that there can be those issues. So I think that's such a good piece of advice, right? To be planning for the future and thinking of these things, right? Okay, maybe I source multiple sources up front, so that way I know we're never going to have to, stop our production line down the road because we don't have any more supply.
Right. And I know it's easier said than done to say, go ahead and have all alternates ready. But, again, we work with clients all the time that have these cases where they've run into a supply chain issue. And sometimes it is as easy as just picking another supplier or another part number off the shelf, if we can help them evaluate whether or not all those, extended data sheet parameters are the same. And we can demonstrate maybe from some other testing that battery's been through, or they're using it in another product, we can show some equivalence there and help them, use that alternate battery pack. So, that's another area, not just using new batteries, but sometimes clients have a similar battery pack in another product. Maybe they can use that across a family of products, and they've already gone through the testing with us. We already have all the data, and we've seen cases where that helps them, get through those supply chain bumps.
Yeah, absolutely. Well, Rich, this has been great. So many good pieces of advice and tidbits to think about, as people are either beginning their designs with batteries or thinking about incorporating them into their existing designs. Anything else you want to leave anybody with? Any other things you want to hit on today?
Yeah, I just recommend everybody be aware that, batteries, whether it's lithium ion or even the other, call it safer chemistries, new chemistries, ones that are considered, oh, these can't catch on fire or whatever. Understand that, we always want to take a bit of a conservative approach here. We know that for medical devices, wearables, especially, you don't want to take, unnecessary risks. They always treat these as potential energy sources, which they are. Whether or not the chemistry is considered safer or less safe than others, there's mitigation paths in the design to help make them, safer for use. So just be aware that any energy source has a potential has a risk potential, and as long as you keep that in mind in your designs and your compliance programs, you're not going to overlook those risks.
Well, that is a perfect final thought to end us today. Thank you so much for joining me. If anyone has questions, they can reach out and email them to me directly, and I will pass those along to Rich, and we will get connected with you. Thanks as always for joining us today.
Thanks a lot. Take care.
Okay.